Hello, ladies and gentlemen. Root Beer here with question number 6 on the 2008 Euclid Math Contest. So, just like the last few questions, it's going to be in two parts. You'll find the middle level Euclid questions tend to be in two parts. I believe 6 here has the last of our light bulb questions, where we just need a final answer. Everything after 6a is going to be entirely written, so enjoy it while you can. Speaking of which, 6a. The function f of x satisfies the equation f of x equals f of x minus 1 plus f of x plus 1 for all values of x. If f of 1 is 1 and f of 2 is 3, what is the value of f 2008? Okay, so they're giving me two terms. And if I rearrange this expression here, I should be able to figure out f of 3. And then knowing f of 2 and f of 3, I should be able to get f of 4 and so on. So I'm going to start writing out a sequence of numbers. Now, I don't think there's anything special about the 2008. I think they just want me to be able to continue this pattern for quite some time. So what we're going to do is we're going to look, f of 1 is 1, f of 2 is 3, maybe f of 4 is something predictable, and then, f of 3 is something predictable, f of 4 is something predictable, f of 5 is something predictable. And maybe we can get a pattern, or maybe after the 8th one, it all just goes 2, 2, 2, 2, 2, 2, 2, and so then we'll know, okay, f of 2008 should be 2. But let's dive in and take a look here. So we're told f of x is f of x minus 1 plus f of x plus 1. I'm going to rearrange this and keep the f of x plus 1 on the side here. But this tells me f of x plus 1, my future term, is f of x minus f of x minus 1. So to get the next term, I take the current term and subtract the previous term. So I know f of 1, so we'll make a little chart here, x. So 1 and 2, we know f of x. We get 1 and 3. And so it still doesn't, the pen does not like the subtle motion of the sort of middle prong of the 3. So we'll go a little slower. There we go. So if I wanted f of 3, well, that would be the difference of the previous 2. So that should be 2. And then f of 4 should be the difference of the previous 2. So that should be minus 1. And you can double check. F of 2 plus f of 4 is indeed f of 3. 3 plus negative 1 is 2. So f of 4, then we go to f of 5. So negative 1 minus 2 is negative 3. And then we get 6 here. Negative 3 minus negative 1 is negative 2. Now look at that. We're starting to get bigger. Okay? So it's 1, 3, 2, negative 1, negative 3, negative 2. I bet the next one's going to be 1. Well, negative 2 minus negative 3 is negative 2 plus 3, because the two minus signs cancel to a plus. And yeah, we get 1. And 1 minus negative 2 is 3. And it's just going to repeat. Okay. So how can I figure out what number is what in my pattern? Well, it looks like it repeats every 6. So the question is, 2008, where does that fall? And to answer a question like this, we ask ourselves, well, 2008, what is the remainder when we divide 2008 by 6? And if you need to, you can grab your calculator. I'm just going to quickly. 2008 divided by 6 is about 334.66 whatever. Subtract off the integer part, the 334, and then multiply by 6 again. So 2008 has a remainder of 4 when we divide by 6. And you can tell here, if our pattern repeats every 6, then it's just up to, well, what's the remainder when we divide by 6? So you notice 10 and 4 both have a remainder of 4 when we divide by 6. They're both minus 1. 16 will also have it. 22 and 2008. So we know our answer is going to be -1. And we can just put that in the box they provide, but I like leaving the explanation that I've given here, a little chart saying, it repeats every 6. This gets me part marks in case I'm wrong. Okay. There's A part done. We've got 6B as well, so let's take a read through for that one. The numbers A, B, C, in that order, form a 3-term arithmetic sequence. And if you don't know what an arithmetic sequence is, pause the video and take a read through here. Looks like we're also going to need geometric sequence as well. A, B, C in that order form a 3-term arithmetic sequence, so we've got a common difference, and A plus B plus C is 60. The numbers A minus 2, B, and C plus 3 in that order form a 3-term geometric sequence. Determine all possible values for A, R, and B. Okay. So, and if you don't know it, arithmetic sequence, each term after the first one is obtained by adding what is called the common difference. So the terms look like A plus D, A plus 2Ds, A plus 3Ds. Geometric sequence, same sort of thing, but multiplication, not addition. So we get a constant ratio. So the first term is A, then we get AR, then AR squared. We multiply by R every single time to get the next term in the sequence. Okay? So I'm going to borrow that. That's sort of standard notation, standard operating procedure when dealing with arithmetic and geometric sequences. So I'm going to say, because it's written as well, let's try and use a bit more full sentence style. Let D equal the common difference and R the common ratio. So A, we're going to call A. B is going to be A plus D, and C is going to be A plus 2D. Now, we're told that 60 is A plus B plus C, but then that's really just A plus D plus A plus 2D, or 3A plus 3D. Just collecting terms together. So that tells me, dividing both sides by 3, 20 is A plus D, which happens to be B. Alright, fantastic. So I know the middle term of both sequences, because it is still, it's B again in the middle for my geometric sequences. Both middle terms are 20. Now my geometric sequence is A minus 2 and C plus 3. So we get A minus 2, and then B is, 20 is B, but that's the first term, A minus 2 times my common ratio R, and C plus 3 is my first term, A minus 2 times the common ratio R squared. So we're applying the common ratio twice. Another way I guess you could say it is A minus 2 is just rearranging. We can get that it's B over R, which is really just 20 over R. And C plus 3 is 20 times R. I don't know if this is going to be more helpful, but it certainly seems to be reducing some of the work, maybe? Okay. So, what could we do here? Well, I know C is A plus 2D, and both of these equations have R's in them, which is fine. But if I multiply them together, this one here is dividing by R, this one here is multiplying by R. So if I multiply them together, the R's will cancel out, and we'll just get 400, which is 20 squared. So 400 is 20 squared, which is 20 over R times 20 times R, and that's A minus 2 times C plus 3, but that's A minus 2 times A plus 2D plus 3. Okay. So, there's another equation. It's got your A's and your D's. I'm not sure this will necessarily go, that this will go anywhere, but let's expand this out. So A squared plus 2AD plus 3A minus 2A minus 4D minus 6. All that's equal to 400. That's A squared plus 2AD plus A minus 4D minus 6. Okay. So that's not the most helpful thing. I mean, it's quadratic in terms of A, but it's got D values in here that I'm not the biggest fan of. Suppose we could group some like terms and say A squared, so we'll say 0 is A squared plus 2D plus 1 times A minus 4D minus 6 minus 400. This term at the end makes me nervous, but okay. Or should I rearrange it and solve for D in terms of A? Oh, yeah. Could I? I feel like I could solve for D in terms of A, and then I know A plus D is 20. So then I'd know A plus something in terms of A is 20, and then I could probably just solve for A, and it might just be a quadratic there. I think that might be a better way to do it. I'm not saying you can't do it with this A. I feel like I don't want a D under a square root sign right now. So I'll try this instead. So we'll keep the D's all together. So 400 plus 6 minus A squared minus A is 2A minus 4D. Okay, so that's 406 minus A squared minus A all over 2A minus 4. And I'm fairly certain that the top here is not a multiple of the bottom. I'm willing to be proven wrong, but let's see. The only root of the bottom is 2, and 2 is not a root of the top, so no, it's not a factor. But now I know D, and we can say something like, recall 20 is B is A plus D. So that's A plus 406 minus A squared minus A all over 2A minus 4. Multiply by 2A minus 4 on both sides. So you'll get 40A minus 80 is 2A squared minus 4A plus 406 minus A squared minus A. 2A squared minus A squared is A squared. Minus 4A minus A is minus 5A. Plus the 406 stays here. 40A here. We'll bring that over to a 45A in a moment. So we got A squared minus 45A. Plus the 80 comes over and it's 486. So the question is, can I factor this? Can I find, and these numbers are kind of awkward, so I wouldn't necessarily sit around trying to think of integer factors of 486. You'll get a 2. So 2 times 243. So this thing is 2 times 3 to the 5. So could I get 6 times 81? No, that's not going to add up. 27 and 18 does add up to 45. There we go. So 0 is A minus 18 times A minus 27. Okay. And so A is 18 or 27. B is 20. and C is then 22, or subtracting 7 each time. So here the common difference would be -7. Here the common difference would be 2. Don't have to work those out. We can just sort of inspect. So C would be 13 here. So those are my final answers, and because we reduced down to a quadratic, I mean, we have equations showing our logical steps each time. We don't need to make some grandiose gesture of, these are the only ones, let's prove that. It's, by the way we logically put this together, these are the only ones. The only thing I would double check is, so the way I've constructed, I got my A's, I already knew B was 20, then I got C by picking out the arithmetic sequence. The only thing I would now do is do the A minus 2's, B, and C plus 3's, and just double check, is that actually a geometric sequence? But other than that, I mean, if you're confident in your answer, that you didn't make arithmetic mistakes, move on, because you've shown enough work. You've shown enough work to get the marks. Maybe 1 or 2 sentences explaining this is what I'm about to do. But I think we've shown enough work. The question is, there's did I make an arithmetic mistake somewhere? Now, the numbers were nice enough, so I don't think I did. But if I'm worried, don't go poring over line after line after line after line. Ask yourself, are the results at the end, do they actually match with what they're supposed to do? And so we'll just quickly, on a separate sheet here, double check. So obviously 18, 20, and 22, that's an arithmetic sequence, but we need 16, 20, and 25 would be our other sequence, and that's a common ratio of 5/4. And then it's 27, 20, and 13, and you're getting 25, 20, and 13 plus 3 is 16. So a common ratio of 4/5 there. That's pretty nifty that it can only be, these two ratios are sort of reciprocals of one another. But there we go. There we go. So I have confirmed to my satisfaction that these are geometric sequences. You don't have to include it. No one's asking for the geometric sequence. They're just being asked to determine all possible values of A, B, and C. So if you wanted to, if you're a stickler for that sort of thing, you could say there are 2 sequences A, B, and C. They are 18, 20, 22, and 27, 20, 13. There we go. All right, so that does it for question number 6. In the next video, if you would like to join me for that, will be question number 7, the first of the last 4 questions, and they are all written questions. So feel free to give them a try, and I will meet you in the next video for question 7.